Sir, please turn on your video, sir. Hello, sir.
Yes, ma'am, I'm here.
Sir, can you turn on your video, sir? Thank you, sir. Good afternoon, everyone. I welcome the resource person and all the participants to the last session of our 5 days online FDP on Advanced Technologies in Wireless Communication Network, organized by ECE Department, GMRIT, Rajam. Actually, today's session is scheduled to be handled by Dr. Ashifa Madam, but due to some medical emergency reason, she was unable to handle the session. And as based on her request, our today's resource person, Dr. Ferddie Quiroz Canlas, is going to handle the session. Thank you very much, sir. Even within a short notice of time, we have intimated you, but you have given your support to us. We are very grateful to you, sir. Let me take the privilege in introducing our resource person to the participants. Dr. Ferddie Quiroz Canlas is currently working as assistant professor in Department of Computing, Muscat College in Oman. He has 14 years of teaching experience in college and university levels, and he also has several years of experience in administrative side, like head of the department, associate dean, and also acted as dean. And he has guided various projects, and he has 9 years teaching experience in graduate school teaching master's degrees, and 12 years software engineering, statistics, and research consultancy experience, and 4 years full-time experience as head of the management information systems, and 7 years experience in educational quality assurance as commission on higher education regional quality assessment team member. His fields of interest include data science, artificial intelligence, machine learning, software and network engineering, and IT project management. And his current affiliations include Associate Fellow of Higher Education Academy UK and also Microsoft Certified Innovative Educator. We welcome you to the workshop, sir. We are very thankful to you for accepting our request. And now you can start your session, sir. Thank you.
Thank you so much, Dr. S. Sri Durga Kamiswari, for the wonderful introduction. Thank you so much. I appreciate it. You took some basic information. Thank you so much, and I appreciate the warm welcome and introduction. So I'd like also to thank the management of the GMRIT for the invitation. I think this is my second time to give a talk. And of course, I would like to thank our HOD and convener, Dr. Nagesh Warao. I hope I pronounce his name properly. And also our principal, Sir Prasad. And of course, our organizer and the person who had the faith in me, even in the last minute, he believed that I could give a talk in a short notice. I would like to say thank you to Dr. Arun, the organizer of this event. Ladies and gentlemen, good afternoon to you all. I hope I am clear and my voice is audible and my presentation is visible to everyone. Just to have a confirmation, everything is clear, my voice is clear.
Yes, sir, your voice is clear.
Thank you so much. I am pretty sure that all of you are very familiar with machine vision, machine learning, and also image recognition. I bet when you wrote your research papers, you have your favorite image recognition models, such as the DPM version 5, RCNN, fast RCNN, convolutional neural network, so on and so forth. So today, I'll try my best to congest everything within 30 minutes because Dr. Arun told me that I have to finish everything within 30 minutes or maximum of 45 minutes. Thank you for the indulgence. I'll be introducing to you actually Yolo, a new player and game changer in the image recognition realm. So this talk targets those who have bare knowledge on Yolo. I mean, those who haven't yet encountered or even have encountered this Yolo model. The topics that I'm going to share with you today are actually from my literature reviews that I am doing currently with my research paper. And I'll try to be brief as much as I can. And in this topic, we'll be talking about the G's or the nutshell of Yolo and the timelines, what were the developments made and what made this new image recognition model attractive to most data scientists and artificial intelligence enthusiasts like me. And we will talk about why Yolo is better than the other existing models of image recognition and what are the challenges. We know for a fact that whenever there are challenges, it is an opportunity for us to do research, right? At least to help to better improve this model and also to participate in the ongoing development. Just to tell you, Yolo is an open source model, so it means it is being maintained by the community and you can also participate upon knowing the challenges we are facing currently with Yolo. And what are the research domains that we can apply Yolo? I think most of the attendees of this today's talk are all educators or even students who are, I think, into research and doing some projects. So this is a better opportunity for you to look at what are the possibilities we can use Yolo. So let's try to define what is Yolo. Yolo is not you only live once, okay? That's not the definition, although it's a bit funny if you look at it. Let's have a brief discussion of Yolo. Yolo means you only look once. So you will know later why it is like this, why the name is called You Only Look Once. It is actually a real-time object detection algorithm, which is one of the most effective. Currently, the developer of this model, they are very conservative. They don't claim fully that they are the best. Instead, they are saying that this is one of the most effective object detection algorithm that also encompasses many of the most innovative ideas coming out of the computer vision research community. Object detection is critical, actually, when it comes to the capability of autonomous vehicles, right? Because we know autonomous vehicles are in motion. So this is a challenge, actually, when it comes to object detection, when the object is in motion. So how we capture it and analyze it and compare it with the test data that we have. So it is actually an area of computer vision that is actually exploding nowadays and working so much better than just a few years ago. At the end of this talk, we will see a couple of recent updates to Yolo and why people are really looking into it and why they collaborate to better improve this model and why the original researchers made it open for everybody and why everyone is talking about this new image detection model. So Yolo was introduced actually in 2015 by the original publisher, the one who developed it. We have Joseph Redmond and his friends. And it was from their paper entitled You Only Look Once, Unified Real-Time Object Detection. That's the title of the paper. If you are interested, kindly read that one, I suggest, so that you can see the entirety of this model. And upon presenting this, immediately got a lot of attention from fellow computer vision researchers like me. When we talk about object detection, in the classical computer vision, the most challenge or the challenges that the current models are facing is what and where. Okay, so we talk about where is the object inside the image. So some the current models, they can detect the image. Let's say, for example, if you look at a dog or a car or a pedestrian lane, they could detect it. But to tell where is the car in the image or where is the pedestrian lane in the image, that's a big challenge for the current models, because we want most of the time we don't only want to do detection, right? We also want to know the location of the object we are detecting in the image set that we are trying to process. So the problem of object detection is more complex than classification. It's more than classification, actually, which is also, I mean, we need to recognize not only the object, but where is the location of that object, as I mentioned earlier. So classification does not work on image containing more than one object only. So that's the other issue, right? There are a lot of dogs, let's say, for example, or a lot of cars in that image that we are trying to process. YOLO uses a totally different approach. I think you have heard about RCNN and the rest of the current model. YOLO is a clever convolutional neural network, CNN. So most of the models we know, they are based on convolutional neural networks, right? But what makes this model distinct from the existing ones is that it can detect object in real time. Even in videos, actual and real live videos, it can detect image. The algorithm applies a single neural network to the full image and then divides the image into regions and predicts bounding boxes and probabilities for each region. So these bounding boxes are weighted by the predicted probabilities. Of course, that will be from your training data sets. You know that one. YOLO is popular because it achieves high accuracy while also being able to run in real time. That's a distinct characteristic of this model. We call it only look once. You only look once because the image, in a sense, we do only one forward propagation pass through the neural network to make predictions. And then after the non-max suppression, which makes sure that the object detection algorithm only detects each object once, it then outputs recognized objects together with the bounding boxes. So with YOLO, a single CNN simultaneously predicts multiple bounding boxes and class probabilities for those boxes. So YOLO trains on full images and directly optimized detection performance. Unlike with the existing ones, when they have complex CNN networks or neural networks, but YOLO, it made it simplified, the design. And later on, you will see how it works. I will also provide you, I think, 1 or 2 slides for that. If you will see, the title of my talk is Into YOLO B5. We currently have B5. If you will see, this model developed very fast. Firstly, it's an open source one, as I've told you earlier. It was originally written by Redman, if you will see in the slide, from 2016 until 2018. The author, the main author, the original author, maintained the model. And you will notice in YOLO version 4, it was now divided into different authors. So you will see we have Alexei Bochkovsky and Glenn Josher. They had their own version of YOLO. They improved it based on the challenges they found. And then not only that, we also have other YOLO versions like PP YOLO by Baidu team. Maybe you know this one. If you are having image processing in your mobile phones, you know Baidu. This is an organization or a company that also deals with image processing. So they improved the previous versions. You will see later what were the improvements made by these different authors. And we also had this Scaled YOLO before by Chen Yao. And then we have PP YOLO by Baidu team. So if you are aware of TikTok, I think these are the organizations behind TikTok. And we have a lot of improvements, and we have a lot of white papers talking about what were the improvements made and introduced by each model. And each model were tested with different testing models like Coco and also Pascal, which I will show to you later what made this YOLO really better than the existing models that we know nowadays. And I think PyTorch also, and even Google is also having their own version of this YOLO. As far as I know, Google is now working on providing tools and training data sets for YOLO. So let's just have to wait for it, and it will be publicly available for all data scientists and artificial intelligence enthusiasts, people like me. So what made YOLO attractive to most researchers in the field of machine vision and image recognition? According to this paper, of course, from Redmond and Ferddie, the original authors of the work, they said that YOLO is extremely fast, and YOLO sees the entire image during training and test time, and so it implicitly encodes contextual information about classes as well as their appearance. So these results were published in 2016, again by the same authors, Redmond and Ferddie, and both of them are from the University of Washington, and they provide a number of improvements to the YOLO detection method. And they claim that this model can detect over 9,000 object categories. Very powerful, right? And also in 2018, they said that upon improving, again, massive improvements they did with this model. By the way, you can see all the available source code and sample workaround of this model in GitHub. It is now a talk of the town. Most of the developers, they talk about it. And you will see plenty of GitHub version of this model. You can see plenty of tutorials. Even when you start typing YOLO in the Google, it will provide you a lot of resources. This is a good thing when the model is an open source one. You could see a lot of community supporting it and providing you a lot of information and training. However, there are challenges we need to look at. As I've told you earlier, as researchers, we can improve YOLO. We can help the developers to improve the work by giving them feedback with our researchers. Let me cite one study, one experiment made by Chablani et al. In 2017. So that was in 2017, and I believe that these challenges were already addressed by different developers of YOLO versions. I think you will agree with me, right? Because the study was in 2017. Anyways, let's try to look at these challenges they faced. You might face the same during your implementation and when you do the experiment, your research projects. According to Chablani and his colleagues in 2017, YOLO imposes strong spatial constraints on bounding box predictions, since each grid cell only predicts 2 boxes and can only have 1 class. So this spatial constraint limits the number of nearby objects that the model can predict. So this is the problem now. The model struggles with small objects. So that's the first disadvantage they saw. It struggles with small objects that appear in groups, especially if they are in groups. Let's say, for example, flocks of birds, because these are their data sets. Because when they did the experiment, they use birds, a flock of birds in their model. So the problem is it struggles to generalize to objects in an unusual aspect ratios also. And the model also uses relatively coarse features for predicting bounding boxes, since the architecture has multiple downsampling layers for the input image. So kindly take note of these challenges you might face during your trial. And finally, they found out while they train on a loss function that approximates the detection performance, The loss function treats errors, the sample in a small bounding boxes versus large bounding boxes. Also, the problem with Yolo is that over-focused images, it's also facing some problem. Too small objects and too large or too focused objects, it's struggling. So those are the disadvantages. And I'm really trying my best actually to look at if these weaknesses or challenges were addressed by the recent versions or developments made into Yolo, but I don't really find ample literature for that. Maybe in the future I could see, because the latest versions I think were just released a year ago, June of 2020, if I'm not mistaken, and we still have a few literatures reviewing the latest version. So let's try to look at why we should consider Yolo. I have taken this test from the Pascal 2000 MAP. MAP means mean average precision. So this is a measurement of precision. Although we also have COCO precision tests. I did not take it in here because they almost say the same thing. But Pascal is the most famous one when it comes to this. So what makes Yolo actually almost real-time? I want you to look at the last row in the table. You will see in there that the Yolo can perform 45 FPS. This is very fast, right? Did you know that our movies and televisions, the videos that we are seeing in televisions and videos, were actually running 24 FPS, 24 frames per second. It means when you watch a movie, in a second, they play 24 pictures, 24 frames or 24 pictures per second. That's the typical movie that we are watching on television. But Yolo can detect 45 FPS. It means it surpassed even the movie that you are watching, the number of pictures you are seeing when you are watching a movie. That's why we call it real time, right? It can detect one image in 22 milliseconds. In short, in layman's term, it can detect 45 pictures per second, which is very, very fast compared to faster RCNN, fast RCNN, so on and so forth. If you will see, faster RCNN is only 7 FPS. Still, although faster, but it won't beat Yolo when it comes to detecting objects, right? And according to some reviews that I have read, RCNN and DPM version 5 they perform very well on static image, meaning when we say static image, image not in motion. But Yolo is perfect on that when it comes to detecting objects in a moving, in motion. That's why they call it a real-time detection model. So how does it work? So how does this model work? Actually, the model, as I told you earlier, it's only using a very simple CNN networks, right? That is because aside from the CNN, it's also using other approaches. Actually, it's using 3 techniques. It's using residual blocks, and then it has the bounding box regression, and it has the intersection over union, or the IOU. I will not discuss much in detail the technicalities of this because I was only given 30 minutes to finalize my talk. So I'll just have to give you the eye view of, the bird's eye view of how the algorithm works by giving you the salient points. So look at this image in here, okay? So first, the image is divided into various grids. I think most algorithms, they do like this, right? So first, the image is divided into various grids, depending on your training. So each grid has a dimension of S by S, okay, depending on your settings, I've told you. But don't you worry, you don't have to do it manually, okay? There are a lot of libraries that you could use to do this one. So there are a lot of Python-based IDE that you could use, your Jupyter notebooks or any software which is capable of running Python. It will help you to do this. And you can also use some online-based IDEs like Google, the Google provided ones. And if you want to deploy it, we have this Alia SDK, or the software development kit. So you try to look at that one, and you can do it independently of this Python-based IDE, and you want to do it a fully functional application. So in the image above, if you will see, there are many grid cells of equal dimensions, right? So depending on your applications, I've told you. So every grid cell in this picture will detect objects that appear within them. So for example, if an object, the center, appears within a certain grid cell, then this cell will be responsible for detecting it. So it means each grid is responsible for detecting each and every object bounded into it, and it's responsible to provide these inputs into the next layer. And then Yolo uses a single bounding box regression. So this is what I'm talking about. So each grid will have to detect the object and report back to the next level. And using the bounding box regression, you can predict now the height, the width, the center, and the class of the objects. So in the above image, you will see it represents the probability of an object appearing in the bounding box. So it will be represented, you see it's a regression, right? So you know how regression works. I don't have to delve much on this. So y is represented by the p, by the b, x, by, bh, bw, and c. So you can see the variables involved in that in the slide, on the left portion of the slide. So basically, the grid responsible for detecting the object will report back the values necessary for the calculation later on. So bw is the width, bh is the height, and then we have the class. So this is the object that you're trying to detect, and the bounding box for that object, which is represented by bx and by. So like other image detection models, you have to train, and you should have your data set to test this model. And luckily, we have plenty of data sets, training data sets for different objects available out in there. Even Kaggle is now supporting this model, and you can see plenty of data sets, training data sets in Kaggle websites. And there is this unique feature that, a unique algorithm that Yolo is using, this what we call IOU, or the intersection over union. This is actually a phenomenon in object detection that describes how boxes overlap. Sometimes boxes can overlap, right? So Yolo uses IOU to provide an output box that surrounds the objects perfectly. So each grid cell is responsible for predicting the bounding boxes and their confidence score, or scores. There are plenty. So the IOU is equal to 1 if the predicted bounding box is the same as the real box. Okay? So this mechanism eliminates bounding boxes that are not equal to the real box. So the following image here provides a simple example of how IOU works. So in this image, there are two bounding boxes, one in green and the other one in blue. So the blue represents the predicted box, while the green box is the real box. So Yolo ensures that the two bounding boxes are equal. Okay, so to sum it all, so this is what happens. So this is your object on the left. First, the image is divided into grid cells. We know that one. Each grid cell forecasts B bounding boxes and provides their confidence scores. And then we have the cell. The cell predicts the class probabilities to establish the class for each object. For example, we can notice at least 3 classes of objects, right? We can have car, let's say for example, dog and a bicycle in this example. And all the predictions are made simultaneously using a single convolutional neural network. So intersection over union ensures that the predicted bounding boxes are equal to the real boxes of the object. So this phenomenon eliminates unnecessary bounding boxes that do not meet the characteristics of the object, let's say like the height and the width. So the final detection will consist of unique bounding boxes that fit the objects perfectly. For example, the car is surrounded by the pink bounding box while the bicycle is surrounded by the yellow bounding box. Then the dog has been highlighted using the blue bounded box. So in this case, we could have distinct detection of the objects that we try to detect. As I've told you earlier, you don't have to worry about it because Python will do the rest of the job for you. You can implement Yolo using Jupyter, as I've mentioned, or any preferred IDE. And you can see a lot of sample codes available in GitHub. I suggest you have to go to Andrew Nang's GitHub page. You could see comprehensive samples on how to do this, even the coding, importing of the data set, importing of the actual video or images you want to detect, training. All of this you can see in details with Nang's GitHub page. We can't do it in here because we don't have the luxury of time to do it. And also it's available in PyTorch. And also, as I mentioned earlier, if you want to deploy it in a standalone application, and then you can go with Alia SDK. So we have plenty of tools nowadays. It's open source, right? So you could expect a lot of tools, tutorials, and even sample codes wherein you can do and start your projects. So let's look at the practical applications of Yolo. So look at the pictures in my slide. You will see in there, I have autonomous driving. I think there is one car, I forgot which brand it is. They are now using Yolo to do the autonomous parking and driving for the cars. I just forgot the brand of that car, but they are now using Yolo algorithm. So Yolo is used to detect objects around the car, such as vehicles, people, and parking signals. Since Yolo can detect 45 FPS, right, or frame per second, it means it's more than real time actually. So it can be used even in a speeding car. It can detect objects in motion, and you can also detect objects while you are in motion. So this could help the driver to avoid collision, right? And so you can even, let's say, for example, replace humans in controlling the car. So maybe for non-critical travels, or let's say, for example, for delivery cars, you can use this algorithm. But of course, it will take a lot of complexities to do that, the hardware and software programming. And I think a lot of papers I have read in my literature review, most of the Yolo implementation are on the wildlife. So the algorithm is used to detect various types of animals in forests. And this type of detection is used by wildlife ranges, let's say forest management people. And even journalists actually are using this model to identify the animals in the videos. Of course, both in recorded and real time. And also the images they have shot. So some of the animals that can be detected, it could range from giraffes, elephants, and bears, like this. But of course, as I've told you earlier, there are challenges for small objects in packs, right? So maybe if you are interested in capturing or analyzing different types of insects, maybe this could be a challenge for you. Anyways, let's hope and pray that the recent or the latest version of YOLO addressed those challenges mentioned by previous researchers. And I think you can work on this security. So YOLO can can be used in security systems to enforce security in an area. So you just have to provide a training data set on here. Let's say, for example, you have your CCTV camera and you have to provide a training data set, like let's say some series of pictures, let's say demonstrating how these bad people try to hijack your car or carnap it or steal it. Just try to provide some training data sets. Of course, YOLO is an algorithm, right? And it depends upon what training data sets you are providing. So if the data sets are not really depicting the things that you want to detect, and then most probably YOLO will fail. But you have to provide a good training data set. GIGO, we need to always look at the principle of GIGO, garbage in, garbage out. If the training data set is garbage, expect that the output of the algorithm, no matter how good the algorithm is, it will provide you garbages as well. So you just have to provide ample training data sets. So I think this is a little bit challenging for you, right? So you have to experiment different poses on how to carjack or steal this car. Let's say how you will do things like this, how you will look suspicious. So you have to provide all these necessary training data sets. And then you can connect it to a different applications, like once this happens, you can take a live video and then send it to you or send it to the police or wherever you want and make the neighborhood safe. So this is the latest version of YOLO. I guess this is YOLO version 5. And it has different variants. And when I was really actually writing this presentation, I was reminded by COVID with different variants. But of course, as I've told you, YOLO is a talk of the town nowadays. A lot of developers are talking about this. If you will see my slides previously, I said it in there. Actually, it's not from me. To YOLO, infinity, and beyond. So expect that we will have different versions of YOLO coming into the scenario. And like Linux, since it is open source, expect that a lot of version will come out since it's open source. So it will be infinity and beyond. It means you will expect a lot of version for this. If you will see, YOLO version 5 itself has variants. The latest version is said to be YOLO version 5. And upon the release, depending on the organization or the authors releasing it, they have different versions, promising different performance. And of course, expect that the focus of the improvements are on the FPS, higher frame per second detection, and then precision. I hope and pray that they already addressed the issues stated by the previous researchers earlier in my talk. And then, of course, higher speed. So if you will see, they have tested these different versions of YOLO using the COCO tests, using the data sets and also the COCO test. You will see in here that we have YOLO V5S, V5M, VL, X, so on and so forth. And you will see they promise different detection. So you will see we have 455 FPS, 345 FPS, faster and faster. As of the records, we have YOLO V5S, which is having 455. It can detect 455 pictures per second, so very fast. And they promise a lot of things. And eventually, we will expect that YOLO V5 for YOLO itself will be a talk of the town, and most of research papers, I'm expecting that they will be using YOLO in the development process. I'm sorry, Dr. Aaron, I extended a little bit of the time you have given. So I exceeded around 10 or 11 minutes of the 30 minutes that you have provided me. So thank you so much for listening. Thank you so much, Dr. Arun. Even for a short notice, you still have given trust. And thank you so much for the invitation. So if you have questions, I welcome your questions, ladies and gentlemen. Any questions from the audience?
Can you hear me?
Yes, doctor, I can hear you.
Sir, thank you very much, sir. It was really indeed a good session, and it is a new topic, YOLO, for all of us, and it is interesting topic also, sir. And as of now, there are no queries. Participants are requested, if you have any queries, please post it in the comment section.
Sir, can you hear me?
I can hear you, sir.
Sir, your
Although it's a
micro
little bit choppy.
mute. Sir, planning for a validation. So it will be started with. So you are the for that validatory session. So you please can you please wait, sir, and uh, my department HOD everyone will join this session and sir, can you hear me?
It's choppy, sir. I don't hear it fully.
Hello, sir.
Please proceed, sir. I'll try my best to understand.
Sir, we are having a plan. The validatory session for this FDP, why because today is the last day and the last session. So we are to invite chief guest for that session. So in connection to that, my department HOD, and some senior professors will join in this. We will have a session by 4:45. Now the time here is 4:40. Can you please wait for 5 minutes, sir?
Sir, our head of the department is about to join within 2 minutes. So once he joins, we will start the valedictory section and we will conclude this workshop within 10 to 15 minutes.
Thank you so much, ma'am. Thank you.
Yes. So now our department professor, Dr. Yogesh Misra has joined. As our head today sir is busy with MBA work, Mr. Sir has joined to our valedictory function. Now I request Dr. Mr. Sir, let me introduce to you to the resource person. We have Dr. Ferddie. He's a professor in Oman. Professor, I request you to share your views regarding this workshop.
Namaskar, Professor sir.
Hello, doctor.
Yeah. So, on behalf of EC department, I would like to just thank you all for giving your time for this program. and definitely it will be a great experience for all the participants, faculty members, and students, because in teaching community, what we have only our knowledge to just propagate the knowledge. That is only the thing. So in this way only we can do the things, and uh, the workforce which is behind organizing this program. So I would like to thank that workforce also, and here especially the coordinators of the program, Dr. Aziz and Dr. Arun Shekhar, and organizing committee members, Dr. Shiv Sangri, Professor Kalyan Chakravarti, Professor Durga Kameshri. So all these members, they have done a lot of efforts for just bringing our idea of conducting this event in real way, right? So really, I am thankful to you, sir.
I also thank GMRIT for always inviting me to your workshops and webinars. Thank you so much. I appreciate it. Thank you so much also, Dr. Yogesh, for your time. Thank you so much.
Thank you, Mr. Sir.
Yes.
Now I request Dr. Aziz to propose vote of thanks.
Sir, good evening, sir.
Good evening, sir. Good evening too.
Okay, we are almost at the end of this session. Thank you very much for accepting our invitation. Yesterday only we have invited you for taking this session. Immediately, without any hesitation, you have accepted our invitation for handling this session in the successive manner. So I am very thankful to you, sir. Why? Because last time that resource person has refused to take that session because of that, because of her personal problem. So immediately we have approached you. Without any hesitation, you have accepted our invitation. Thank you, sir. So in this time, I would like to thank Mishra sir for attending this session, and you have shared your thoughts regarding this FDP, and you have given your thank to the resource person, Ferddie sir. Thank you, Mishra sir. Then I would like to thank the resource person who handled the sessions from the beginning. This is the 5 days FDP session. So the first session was handled by Rose Ovia madam from USA. Then second session, Dr. Amala Nirmal Das from Oman. Then Dr. Priyan Malarvali Kumar from South Korea. Dr. Korgan Zengis from Turkey. Dr. Ferddie from Oman. Dr. SVN Sandosh Kumar from VIT Chennai, Dr. Mahib Badri from Maharashtra, Dr. K. Krishna Kishore from GMRIT, Dr. Arun Shekhar from GMRIT. So I, with immense pleasure, would like to thank my heartfelt thanks to all the resource persons who has given their effort to make this session as the successful one. So in connection to that, I would like to thank the organizing committee members, especially Dr. Shivasangari madam, Durga Kameshwari madam, and Kalyan Chakravarti sir. They only have given lot of efforts in the back end to do lot of works like anchoring, like feedback form collection and attendance monitoring, report preparation, preparation, and so on. So this is the time to thank them in a very grateful way. So I thank all of them who has given their support in different aspects. Again, I would like to thank two students who are my project students. They have also helped for this FDP in various aspects. I would like to thank Ashanya, and I would like to thank Sushmita for giving their support in various aspects like schedule preparation, brochure preparation, and so on. So apart from that, lastly, I would like to thank the participants. Everything we want to achieve, we should have a burning desire. In that case, I would like to thank the participants once again. and I would like to request the participants to do some effective research in the area of wireless communication and all. Why? Because without research, nowadays it is very difficult to survive in the field of academics. So I would like to request all the participants to do effective research. Whatever the field you are doing, it is not a matter, but whatever you are doing, that should be in a very effective way. That is very important. So I request all the participants to do that very carefully. Once again, I will give my heartful thank to all the participants. Why? Because without them, this FDP session will not be that much effective. So a lot of queries they have asked in various sessions. I thank all of them once again. Thank you one and all. Thank you very much.
Now we sign.
Sir, on behalf of GMRIT management, once again we all thank you, sir. Now we are signing off this session. Thank you, sir.
Thank you so much. Thank you so much. You're welcome.
அவர் இருக்குன்னு நினைச்சிட்டு இருக்காரு.